Okay, good morning. We're going to take a look at how geometry in a basic way and how 3D solids are constructed and related to two-dimensional geometry. And that's where you got to pay attention to it, identifying three-dimensional figures, the difference between two dimensions and three dimensions. Okay, starting here, words you've heard but you might not think about too much. Okay, first of all, a plane is a flat surface that goes on forever in all directions. We usually model them, that's this green, it looks like a parallelogram, but it's just to represent it goes on without end. We can't draw one. You have to use your imagination to understand the infinity of it. The figure at the right shows the rectangle ABCD. Name that because you start in one corner. When you name a shape, you go from corner to corner, vertex to vertex. So we start at A and we follow it around, A, B, C, D. So it tells you how to draw and trace the rectangle. Line segments AB, so I want to point this out to you guys when I'm talking about it. AB, that's this, two letters. They tell me where to go, AB and DC. So I start at D and I go to C. They are coplanar because they lie in the same plane. That's plane J, that's that green plane. They're also parallel because they'll never intersect. That's in two dimensions. This is flat. So AB will never intersect with DC. No matter how far we extend those lines, they will never touch. Something we're familiar with. But we're more familiar with lines in a plane because we've been doing planar geometry, the coordinate plane, with the graphing that's two-dimensional. It goes on side to side and up and down forever. But there is three-dimensional space in which we live. And when two lines within a plane can intersect, okay, or be parallel, there are different ways that planes may be related because planes are two-dimensional. So let's take a look at planes. It's a little different, okay? Just as two lines in a plane can intersect or be parallel, there are different ways that planes can be related in space. First, two planes can intersect and form a line. All these points they have in common. So remember, these planes go on forever. They look like rectangles. That's to give you an idea. Okay, more than two planes can intersect. So when two planes intersect, they tend to form a line. Okay, it's like where the walls come together at the corner. That corner represents a line. Okay, now if three planes intersect, they could all intersect and form a line, but they can also intersect and form a point. It's hard to see with these drawings, but here's the same one. There's the blue plane, and then here's the green plane, so they form a line here, but then look, this plane underneath is going different directions, so when they intersect, they only intersect at that point. Kind of forms the corner of a box. And of course, planes can also be parallel. They have no intersection. They're called parallel planes. Okay, now that's what can happen, and from there, this is how we can construct different three-dimensional figures. Okay, basically put together with two-dimensional sections of different planes where they all meet at a lot of things going on at one time. Okay, so we're really going to look at how we name these things, the different parts of them. Well, let me show you. Okay, intersecting planes can form three-dimensional figures. Okay, that's important. A polyhedron is a three-dimensional figure with flat surfaces that are polygons, hence polyhedron polygons. Prisms, let's change the color on that. Prisms and pyramids are both polyhedrons, a different kind. Some terms we must come to learn. The three-dimensional figures are edge, face, vertex, diagonal. Okay? Edges, that's important. Edge, where two planes intersect in a line. Okay, so like here, G to H. Alright, that's an edge. FG, that's an edge. We usually use dotted lines to draw the lines you can't see. This was solid, you couldn't see through it unless you were Superman and had X-ray vision. Okay, so edges we name with 2 points. to tell us which way we're going. GH is different than GC. Okay, a vertex is where three or more planes intersect at a point, like this plane, and this one on the bottom. The vertex. Think of it as a corner. We usually name those with one letter. Okay. The face, that's a flat surface. It's a section of the plane we're using. We'll name a face with, depends on the shape of the face. But we name the face going from one vertex to the other that makes up the face. Like this face here would be called A, B, C, D. Okay? And a diagonal, that's a line segment whose endpoints are vertices that are neither adjacent nor on the same face. So you wouldn't draw one from C to A, but they're not adjacent, so they're not touching each other. Like H is adjacent to E, it's adjacent to G, it's adjacent to D. It's not adjacent to B, so look, it's going through space. That would be considered diagonal. It's on the same face as A, so that wouldn't work. C, it's on the same face, so that wouldn't work. Okay, that's the diagonal. Now, check this out. Line GC, okay, let me trace over those. Here at the bottom, GC and DA do not intersect. Okay, but they are not parallel either, because this is three-dimensional. We're in space. Okay, they do not lie in the same plane. So lines that do not intersect but are not coplanar are called skew lines. We don't have skew lines in 2 dimensions, but in 3 dimensions we do. 3D has skew lines. Lines that don't intersect but are not in the same plane, like DA will not intersect GC. Okay, they will not touch each other because they're spaced out 3-dimensionally. They don't travel in the same directions, but they're not in the same plane either. So that's what skew lines are. All right, that's a lot to keep memorized. So let's take a look at one of these figures, and we'll practice naming all these. This is something you'll be asked to do. Okay, so you definitely want to watch this video if you need some help later. All right, what I've got coming up here, as I'm waiting for it to load, there we go. Okay, is basically a cube, and we can do some things with this. So I want to show you one of the things I'll ask you to do, which would be to name the various parts. For example, okay, let me get to my text box here. Let's make a list of all the vertices, okay? Notice I said vertices. That's plural for vertex. We don't say vertexes, okay? One vertex, more than one vertices, okay? Oops, did I hit that? Come on, behave. Having problems here. Okay, one of the things they'll ask you to do is to name all the vertices, or name each different vertex. That's where 3 planes come together. You can see it there. Basically, think of it as the corners, and they each have their own letters, so we can literally just start and go around. You've got A. Whoops. Another one is obviously B right here. Then C. Then D. That takes care of these vertices. We come up here. We got E right there. F. Whoops. G. And H. Vertices are straightforward. Okay. Don't know why I have them underlined. In fact, let's take that off of there. There we go. So, naming the vertices, it's like naming the corners. Okay? This is on polyhedron. This particular type is a prism. Okay? You might call it a cube, but it is a prism because its faces, it has two faces. You call it rectangular prism, you could call it a cube if you know for sure. The next thing I would ask you to do is name the edges. Okay? That I want to underline. So, edges. Edges. That's where two planes intersect at the line segment. If you look, there's a lot of edges on here. And you name those with two letters, okay? That's important. So an edge like there, whoops, let's do this. Let's go back, change that to an arrow. Arrow, there we go, that's what I want. So look, like there's an edge. There's an edge, okay? A lot of edges. So, easiest, let's go around the bottom first. This takes a little bit of time, but it's doable. Okay, so edges. We've got, I'm going to change the size of this, make this a little bit easier on our eyes. So we've got AB, and then we've got AB, then BC, then CD, and then DA. We just went around the bottom. Okay, now we go around the top, we've got EF, FG, GH, HF. Whoops, F. Okay, we took care of here, and if you switch the order of the letters, it's okay. Picking up where we left off, the dog freaked out and the phone started ringing, so hey, nothing like a pause button. We've named the edges along the bottom face, along the top face, and now we need to name these edges that are connecting the two. And you can see them if we start here. Okay, or at A we got AF. Oh, you're gonna do that to me now. There we go. We got AF, DH, CG, and BF. Not AF, AE, excuse me. No. Yeah, I got my nose wrong. Dude, my letters wrong. That was AE, excuse me. The E and the F look the same. And then here it goes from B to F. So there's 12 edges. 1, 2, 3, 4 around the bottom. 5, 6, 7, 8. 4 more around the top. And 9, 10, 11, and 12 around the outside. Now the other part would be faces. You name a face. Oops. We name faces. Faces are named with all the vertices that make that, and there's going to be a lot. This is not a fun process, but it is something you need to understand so you know what you're doing. In fact, I want you to take a look at something real quick. We'll show you here as we do this. If you look at the faces, I could cut this and peel it apart. And if you watch, you can see it kind of, the faces kind of fall off, and each face is a square, including the one on the bottom, or a rectangle, because you can see, yeah, they're 2 by 2. You can see on the grid underneath. So look, the grid, two-dimensional, and then space, it's coming up out of the grid, so that's 3 dimensions. 1, 2, and then 3. As you see it open and close. Okay, so I'm going to try to pause it as it closes before it starts to turn back up, or right as it opens. So you can kind of see it as it folds down. So the one face on the bottom is ABCD. Okay, and we have to name it. We have to name it with all 4 vertices, ABCD. That's one face. Quit underlining. Gotta remember to turn this off. I'm doing this because it takes a while, but ABCD. Then you look, you've got the top face, right? It's easier if you keep track of where you're going, which is EFGH. We're just naming them with the vertices going around EFGH. Okay, so that would be considered the bottom and the top. Now you got the front and the back. Okay, if you look at the front, B, C, G, F. You just follow around like a circuit. B, C, G, F. You can name them other things as long as you follow the circuit, as long as you follow the circuit around. Okay, we got the back, which is A, D, H, F. A, D, H, F. Then we've got the right and the left sides. So we got here, A, B, F, E. And you've got way back over here on the other side, which is C, D, H, G. I just followed around. Okay, those are faces. Any diagonals? Diagonals, there's only be a couple. It'd be from a corner, from one vertices to a vertices that's not in the same plane. So if I was drawing them, you'd have like that. That's one diagonal. Okay. You'd have from here to the back corner there. That's two diagonals. From here down to this corner, that's three diagonals. And from here to here, that's four diagonals. That's all we can do. They cut through space. But that's how you name vertices, vertex, edges, faces. Vertices, like the corners, where three planes come together. Edges, where two planes come together, or in this case, two faces, so there's edges. And then faces are the various shapes that kind of construct it, that fold back up. If you watch, whoops, get off of that. I click the play button. You can see the faces, they fold back up to make the solid we were talking about. And closes again. So we'll stop it there. Let's move on. Okay. Now, we can, if a plane intersects the three-dimensional shape, and a plane is this flat surface, and it looks like a rectangle or something, you can think of it that way, kind of like a sheet of paper, kind of like when you cut a stick of butter with a knife. The knife is the plane, the butter would be the solid, it'd be a three-dimensional shape. Okay, so it says describe the shape resulting from a vertical, an angled, and a horizontal cross-section. So when they cut, now they kind of tell you, but it's hard to see, so I got something for you. But you've got to kind of visualize this. Now with pyramids, it's one thing. So it said describe the shape resulting from a vertical, angled, and cross-sectional, horizontal cross-section of a square pyramid. So a vertical slice would be if we just slice straight down vertically into the pyramid right through the peak. And you can see, like here, in fact, let me try to show you using the line tools again. Okay. That would be what you'd see if you were looking straight at and you get this triangle. Now, if it comes at an angle, and I'm going to show you better in a sec, this is the part that we'd see. It's the part, if we took this out, the hole, so to speak, and it would make what they show as a trapezoid. And if you saw it at an angle, and I'll show you that in a second, and if you cut at a horizontal, if it's just cutting straight through it horizontally, you're just going to get the same as the base. The base in this case is a square. The reason it's called the base is it's a square pyramid. The base is the shape that gives it its name. This pyramid's a square pyramid because there's a square and then it's a bunch of triangles that come up. I do the same thing when we name prisms. The shape that gives it its name is the base. Okay, I'll show you. Take a look. We'll make this make more sense. Same situation. Okay, let me let it load. So I'm going to have a square pyramid. See the square pyramid? Now, I want you to see this plane, this first plane, it's going to slice it at an angle. I'm going to start with the angle. Okay, if I click show the plane, doggone it. Let me change this to my arrow. There we go. Go away. Can't we do that? There we go. Okay, you can see it kind of, this one looks like kind of at an angle, and I'll show you. Show the cross section. You see it? It's hard to see this angle. It's cutting slightly through it, but see the purple? That's the way that it's cutting through. And I'm going to rotate it, so you have to watch this move, okay? See, it's showing you from the backside how it's cutting it. It's not cutting it vertically, it's cutting at a slight angle. It's hard to see. But that part in purple, that's where the plane is intersecting that three-dimensional shape. That's where it cuts it. So that's a flat surface. It's a two-dimensional shape in there. That's the trapezoid. Now, watch what happens if you cut it straight down vertically. It would just be a triangle if it came straight through there. If we didn't see this, it almost looks like one. But now watch, if we cut it horizontally, check this out. Okay, look, the plane's cutting it horizontally. What would the cross section look like? Well, watch when we change the view. See it? This darker blue, in fact, show the cross section. See? Now watch. If I slide that down towards the bottom, that square gets bigger because it's cutting a bigger chunk. Pyramids get tinier as they go to the top. Okay, and if I change that view back, see, it doesn't stop in between. It keeps rotating it back and forth. You kind of see it's just cutting at the tip, but that's what it would look like. So that when we do a cross section, you have to imagine. Okay, so now, whoops, now it's cutting it diagonally again. It shows it to you. Okay. Now I'll flip it back. That's that trapezoid. Now, there it is. And if I move this down, look. Okay, if that plane intersects towards the middle, you can see that's that square you're going to see. That's what it cuts. When they ask for a cross section, it's like if you cut that and just slid that out. Like you pulled out that slice, like a pat of butter. Okay, that's what the cross section looks like. And that is what we'll be dealing with today. So there's a short worksheet just to see if you get it, and we'll spend another day with this. It takes a lot of visualization. You have to use your imagination. Hopefully this helped. Okay? Yeah, like this. Check it out. Whoops, let's go to this. Describe the shape resulting from a vertical, angled, and horizontal cross-section of a cylinder. Okay, what's a cylinder look like? Well, maybe I can help you with that too. Whoops, not there. Let's go into here. Okay, let's look at a cylinder. Watch this. I'm going to bring this up. We'll show you everything he talked about. Because a cylinder is not a polyhedron. It's made with, okay, cross-section cylinder. I think we got the same thing we had before. Let's hold on. Let's put it on. I don't like the one I was using. Cylinder, cylinder, cylinder. There it is. Okay. Easier to see this if we mess with it. Okay. So if we show the plane, see how this one's kind of cutting it at an angle? Well, what's that look like? We'll show the cross-section look. It still looks like a circle, doesn't it? Okay, you can still see it. What about if we cut it vertically? Okay, if we cut it straight up and down? Well, then it's going to look like a rectangle if you cut it straight up and down. Okay, because you'd be cutting this. That's the hardest part. Okay. And then what about horizontally? Well, it kind of shows you there. As you rotate it around. No matter where you cut it horizontally, it's like a roll of quarters. You're just taking one of the quarters out of the roll. Okay? And there's what I was talking about. There is the horizontal, or the vertical cut. If you cut through the cylinder vertically, look, you can see it. It makes a rectangle. I'll take that out. See how it cuts through there? See? That's what we're talking about. So that gives you an idea. You'll be asked a couple of these.